CPU-based encoding definitely has its place, like for encoding video on demand. However, live streaming producers encoding with CPUs might as well be throwing their money and our environment down the drain. A proposal written by our partner Jetstream, covered by Jan Ozer in our latest blog article, illustrates this point. Jetstream's marvelous appliance is called Deep Edge OTT server. It is an ultra-dense, scalable OTT streaming transcoder, transmuxer, and edge cache that incorporates 10 NETINT T408 transcoders. Let's get some more insight from Jan. Hey, Jan, I have a question for you.
Shoot.
How does Deep Edge compare financially to a competitive product that provides similar functionality but uses CPU-based transcoding?
Typically, an ASIC-based transcoding product is going to be between 5 and 10% more efficient than one that uses the CPU. And that's solely a function of ASICs being specifically designed for transcoding and much more efficient at doing that than a host CPU.
It is not the complainers, but the impatient ones who move the world forward. They simply get fed up with forever trying to get around and trick the existing solution into doing what needs to be done. To step away from what is to what could be, Jetstream conducted specific calculations based on real situation. Jetstream case is very encouraging for NETINT as the numbers align and confirm the calculations and tests that you yourself previously performed and described. Can you shed some light on those calculations?
Of course I can. What Jetstream did was apply 3 different calculations for a customer who was contracted to supply entertainment to compounds in the Middle East. And we looked at ASIC-based transcoders and CPU-based transcoders. And the top calculation here is for 80 full HD channels to their customers. This is one installation. And what they found was that a single Deep Edge server, which is running with the T408 transcoders, the ASIC-based transcoders, could provide the same throughput as 5 servers using software only or CPU-based encoding. And the costs associated with that, of course, were 5 times the server cost and also 5 times the storage cost and 5 times the electricity cost. And that's how we get to a 1-year difference of around 21,000 euros or 22, and a 5-year difference for this 1 server versus 5 servers of 166,800 euros. The second scenario is doubling them. And here we found that 2 Deep Edge servers, the ASIC-based transcoders, could provide the same capacity as 9 CPU-only encoding servers. And then you see the CapEx and the OpEx differences there. Over 5 years with a 2-server installation, the difference was 293,000 euros, pretty substantial. And then here we see 10 sites, which is, each site has two servers for redundancy purposes. We've got 10 sites, we've got 90 servers if you're doing CPU-based encoding. We've got 20 servers if you've got ASIC-based transcoding. And you see how the CapEx and the OpEx numbers flow here for a total difference over 5 years of around 3 million euros. Quite substantial given the initial investment.
The numbers are very much in favor of ASIC-based transcoding and solution proposed by Jetstream. Is that an isolated case, or can it be repeated in different situations, different type of implementation? How does the capital cost and operating cost, CapEx and OpEx, compare when we look at ASIC-based and CPU-based transcoding side by side?
The numbers are going to be pretty consistent. The bottom line is that an ASIC-based transcoder can do the work of between a half or a full CPU-based server. So it's always going to be much more efficient on the power side. And if you put a bunch of those in a single server, you can get the same output as between 5 and 10 standalone servers using CPU-based transcoding.
Let's start from blank canvas. Explain to me why would someone consider switching from CPU-only based encoding to ASIC-led encoding?
Interesting question. if you're midstream and you have a lot of equipment that does CPU-based encoding, everything's up and running until you're always going to be reluctant to switch. But if you look at the OpEx side of it, the power cost, you should be able to recoup the cost of a ASIC-based transcoding solution in anywhere between 6 to 18 months. And that's the financial side. The environmental side is just as compelling. You're going to use between 20% and 10% of the power for an ASIC-based transcoding system as you would for CPU. So if you care about the OpEx, you care about the environment, it's something you would consider doing, even if you have a CPU-based system up and running.
Of course, we know that ASIC-based acceleration is much more efficient than encoding software on CPUs. We know that it is decreasing operational cost and carbon footprint by order of magnitude. For example, at full load, the Deep Edge appliance draws under 240 watts. To me, that seems like a pretty big deal. Amazing gain from the individual company revenue perspective, but also from the greater good perspective, like what are we leaving to our children? So let me ask you this. Why would someone not jump onto the wagon and not look into implementing this new technology right away?
I think everybody who's transcoding live stream should be looking at an ASIC-based transcoder right away. I think there's no reason not to.